So today we are gonna talk about linked list, and let's start with why there was a need of linked list. Let's start with the basic intuition that what might be a linked list. So maybe most of you guys have heard of treasure hunt game. So what happens in treasure hunt is that when you go inside a room, you find a clue that in which another next place you have to go. So the clue which you get navigates you to the next place which you want to get. So similarly in the linked list as well, there are certain things which guide you to the next place you want to go. So and arrays in which arrays is like there is when you have to do insertion in array. So you can't increase the size of an array. So if you create an array of size 5, then you can't increase that size of array to a size 6. Then you have to make a new array of size 6 and then you have to copy its content from 5 array to 6 array and then you have to delete the contents, delete your array of size 5. So the problem statement is why the linked list was invented. So majorly there are things like you know arrays arrays has a very definite uh, st- size, right? Arrays are fixed in size. So one problem is fixed array size, right? Fixed array size. And then another one was that deletion and insertion in arrays are expensive. So what I mean by deletion and insertion is expensive is that whenever we need to insert an element in array, then we have to access that element and then we have to insert that element in an array. And if we have to delete an element, then we have to create a new array and then do similar way as for the insertion. So putting an element and insertion are different things. And one more thing array is that a continuous memory is needed. So what is a continuous memory? Right? I hope you remember that array needs continuous memory, right? So I have an example to demonstrate it. What is a continuous memory? So there is a sample code here. I have declared an array of size 100, and then I'm creating my own size. That I will this line of code just will ask me that how much elements I want to fill uh, in my array which is created of size 100, right? And then I will take that input in my this variable of size, right? And then one by one I will fill up the first five, let's say I input in 5 as my size, then I will first input the first 5 elements in my array of size which is 100, and then I will print the output elements which I have put in my array, and then I will print the base address of my array and show you that how the arrays elements are given the continuous memory allocation. So let me run this code quickly. And first, right, this it's create this, then it's create this variable, and now it is asking me enter the number of elements, and max is 100. So let's say we take a sweet number of 7, and then I hit enter. So it is asking me, right, if you remember the index from array starts from the 0th position. So let's enter the first element, let's say 29, then second is 23, 20, then 18, 30, 22, 23, 26. So I have entered the 7 elements, and then the array visualization is 29, 33, and so on. So the base address of our array, base address is the address of the element which is at element 0, like first element in your array. So it is this address, and then integer, we created an integer array. So integer consumes 4 bits, right? 4 bits of a memory block. So if you observe 0x BB0. So the next element is BB4, and the another one is plus 4 BB8. And if you know the hexadecimal coding of this, 8 plus 4 will be C, then B will move to C and 0. So similarly, they are all increasing in a continuous memory allocation, right? So memory is allocated constantly, continuously in an array. So now we know that there are certain challenges that arrays of size fixed, insertion deletion is very expensive, there is continuous memory allocated to an array. So that's why we need a linked list. And linked list is similarly that in your treasure hunt game, if you move to a room, then the room will it will give you the hint to the next room, and which there is a clue. So now the question is, what is a linked list? So the linked list is like a linked list is a linear data structure, right? Because it is not in a fashion where it is inside one another thing, but is linearly points to the next element. And linear data structure consists of nodes. I will discuss what are nodes, and each what are nodes is that each node stores the data. Each node has two parts. Let's say each nodes are divided into two parts, which has one part has data and second part has a reference. Reference. Which reference does it has? Reference of next node in the sequence. So one stores the data and another stores the address of which next he has to go. So unlike arrays, the linked lists are not in continuous fashion. So if you remember our theater example, so let's say this is like a theater 1, 2, 3, 4, 5, 6, 7, 8, and so on. And let's say that I use a highlighter here. This is filled, and this is filled, this is filled, and this seat is filled, and these are filled in a continuous manner, right? So what linked list can do? So for your for your array, if we need to create the size of array 4, then we need to take all these 4 elements, right? These 4 in a continuous fashion. But for the linked list can take this one, then this one, then this one, and then this one. So memory efficient, like these blocks of memory don't get wasted in our disk or a drive. So that is a way the linked list works. And then there's our linked list and how a linked list is represented, right? So a linked list is like this. So this is a node. Let's say I will write a pseudocode, right? This is known as a pseudocode that you are not written a code, and it's like node. It's a say let's a node class, and then there is a node star. Star means a reference pointer, and there is a data. It's like this. So this data, let's say I'm assuming is this to be an integer, and this is the address of next. So this now, let's say that this is your linked list, right? This is a node. This is a node. This representation of a node. This is a data 4, and this points to your next data. This is a data 3. Then this is a node, like 2, and there is a 1. So this is address which has address of this one. So let's say this is a number of 332. This can be a number of 295. These are the memory numbers I'm seeing. Memory address, address of a memory, right? These are like this. I'm just using something random numbers for clarity here. And this is like this. And let's say this is our number. So here it will be written CX295. So your this node will point to this node, right? And then this node will point to this. This will point this. So last node. Let's say there is a last node. So whom will this point to, right? This is a very important question. So this will point to null. This will be empty. So if we found an empty, then it is our last element in our linked list. So this is a linked list of size 4, and there are certain reference which point to the next element in the list, right? So this is your linked list, and this is a visual representation of a linked list, and then I'll tell you analogy is that like in a treasure hunt inside a room, it's as a hint of a next room, or you can say, right, there are train coaches which are also connected in similar fashion. Each coach can be moved independently anywhere, right, in the train. So arrays are like, so if it would be array, then it would require a constant memory space, 4, 3, 2, 1. And right, if you need to enter, here an element, or like say you want to enter a 0 here. So what you need to do, you are 4, 3, you will enter 0 here, and then you need to shift 2 backwards, right? 1 will come here, you will make space for 2, and then 0 you can enter, right? But in a linked list, what you can do, uh, there, and in a linked list, what you can do, you want to add a 0 after 3, right? So you will add 0, you will create a node of data 0, and then what you will do, you will point this one to 0, and then you will point this one to your 2. So this is how easy instruction is in a linked list. And if you want to delete this node, let's say you want to delete this 2 node, right? So what I will do, I will just erase my pointer, and then I will point this to 1 directly. And one more important thing which we have to carefully do is that we have to remove this 2, and we have to free the memory which is allocated to this 2, right? So we have to delete this one. This will be deleted, right? So just erase this out. So it will be like this. And here if we want to delete, let's say here I want to delete this 2, what will I have to do? 4, 4, 3, 0. This 2 will be deleted, and so I have to move 1 at 2's place. So let's assume I have a very long list here. Then I have to move one place, every element of that array uh, front, right? One place ahead. So that's why the insertions and deletion in a array is expensive, and here it is very easy. Size is not fixed, it is dynamic. Spaces are utilized more efficiently. That's why we need a linked list. So arrays also have some traits which are very helpful, that directly we can access any pointer. So it is at position 1, then I can access the array as like array of position 1, and then I can access this. So these are certain things which we have. And if we talk about real world analogy, that where the linked list is used, so your linked list is used in something you might have done in Chrome, right? In Chrome you might have done this thing, which is backward and forward tabs. So right, you move the tabs back and forth, Chrome. So that is a linked list which is happening. That is a back, front and back. That is a doubly linked list. I will tell you what is doubly linked list. It's very simple. And then in the music also, right, you move back and forth. Doubly linked list is just like, it will also have a one more pointer here, here, and then that's point to the previous list. So it is completely, you can move forward and you can move backward. We will talk in doubly linked list, and circular linked list is also a linked list type. So we will talk later. Circular linked list is just that the last element of the linked list points to the first element. So then it's become a circle. So it's a circular linked list. So music playlist back and forth is also linked list, and then undo redo is also linked list. And you know, there is one very interesting concept, is a very question in a DSC currently, LRU cache, which will also we will do. So that's all about linked list, and this is how we will code our linked list. Let me just talk about doubly linked list now. So it might be a little overwhelming, but just bear with me. It's very simple. So these have of three memory blocks. So second, it's like this. It has three things. So let's take this. So middle we have our data, and then this one will point to your next, and this will be provide to the previous node. This will be provide to next. This will be provide point to the previous node. This will be null as it is a tail, right? The last are known as tail, and the front is known as head, and this will point to back. This will also be null. So its data structure will be like for the doubly linked list is like node star. There are two memory references, data, and then again our node star pointing to the star is just address reference. Sorry for my bad handwriting. This is just address, and then this is your double linked list. And here, if this points to the first element, then it's a circle, right? It's like node, then next one, node, then next one, and then node. So this is a circular linked list. So this is a double linked list, is a circular linked list. We will use this later when we will solve the questions. So that's it for this one. Thank you guys.